In terms of charging electrostatically, there's three main methods. Charging by friction. That's just a fancy word for what? When you charge by friction. You take two things, and they just what? Rub against each other. Most common way to generate static electricity is the early Greeks discovered this when they used like amber rocks. And amber you could think of kind of like our plastic rods and fur and all that, okay? So anyway, what happens when you rub plastic and fur together? You guys remember? Do we make electricity out of nothing? We don't, right? We just transfer charge, right? That's by friction. One thing likes to give away electrons. In this case, the fur. One thing likes to grab it. And we got charge transfer, okay? Charging by contact just means to what? To touch, right? And I'm going to just touch the sink right here so I get rid of the charge. The last one's charging by induction, okay? Charging by induction is the hard one because it kind of combines all three. It's a three-step process. Let's break this down together, okay? Step one in charging by induction, okay? Actually, I'm going to type and then I'll draw this out because I got lefty chicken scratch. Here we go. Step one is you want to polarize, okay? You want to polarize the object. So what do we mean by that? Here's an example, okay? I'm going to take a plastic rod that's negatively charged. So what does it mean when it's negatively charged? It has extra what? Electrons, okay? And here's what it means to charge by induction. Induction means you never touch it directly. It means to charge indirectly, okay? Remember from biology class, or if you're in that one where you have to like wear the fake pregnancy belly or whatever? My wife always wanted me to like get one of those when she had like, you know, each of our kids in utero there, to wear it around, you know, like kicks and all that, like, you know, and I'm like, oh, I have a bad back, and they need them for class. She's like, whatever, okay? But oftentimes for women, their first child does not want to come out because the kid's smart. It's warm, it's nice, they get free food 24/7 through that umbilical cord, whatever. So doctors have this great thing called Pitocin. Yeah! So when the doctor came in and was going to give my wife that, I almost like gave the doctor a big hug there and high five there because it induces labor. It brings about labor to get the baby to come out. So think of it that way, except we're not making babies now, we're making electricity, okay? So if I bring a negatively charged rod next to an electroscope, you guys remember what an electroscope is? An electroscope is an object designed to detect what? The presence of a charge, okay? I'm going to use this circular electroscope. You guys use the one with the gold foil leaves. It's the same idea, okay? How does this circular one work here at the front? Really quick, let me flip over to my little webcam here. There we go. The circular electroscope just has a metal lightning rod and a metal needle, okay, to detect the presence of a charge, okay? So here, in a neutral state, the lightning rod, okay, just sits there. There's a metal shaft, okay? And then something's going to happen to the needle. Let's see if we can predict this. What happens when I bring this close? What can the negatively charged rod attract to the top of my electroscope? It'll attract the what? What will attract to the top? The rule is opposites will what? Attract, and likes will what? It will repel, okay? It's going to push negative charges down the lightning rod of the electroscope there, and then also onto the metal needle. So the needle we should predict will do what if it has electrons on there? It will stay together or swing apart? It should swing apart, okay? This is called polarization, because notice, actually I should have only drawn 4 charges on here, okay? So I'll just get rid of one, something like that, okay? I didn't actually charge up my electroscope. All I did was I separated out the charges. You see that? So what's the net charge on the electroscope? It's still a big fat what? 0. I'm just separating it out, okay? You see that? That's called charge polarization. That happens with lightning. When a big thundercloud, instead of a cheesy little piece of rabbit fur, 2 miles across, above your head, charged up from cold air and ice crystals rubbing against the cloud there, the water molecules. If it's right above your head, it can separate the charges in the ground, okay? So let's take a look. Let's see if we can actually do this here. On my little webcam, okay, a little magic here, okay? Charge this up, and if you watch closely here, look at the needle. Levioso, okay? Notice it's separating. You see that? Did I actually touch it? I didn't, okay? And when I remove it, it looks like the presence of the charge goes away, okay? So polarize means to charge indirectly. Now today it's kind of humid, it's going to rain, so a lot of charge is going to build up or not build up on a wet, rainy day. You guys remember?
Going to build up.
On a rainy day like today, the water in the air, let's say this thing's negatively charged, will attract the positive hydrogen side of the water molecule. It'll grab the charge and spread it out. So that's why you don't get shocked in the summertime, really. It's always more in the wintertime when it's really dry, when you need the chapstick and the lotion there. Okay? Next, step 2 of induction. Okay? Here's what's kind of weird. Step 2 of induction is we have to ground our source here. We have to ground the object. Okay? So here's what's going on, guys. Okay? We have our negatively charged rod. So anyway, we take our negatively charged rod, we hold it up to our electroscope, but then we ground it. What does that mean when you ground it? It means you provide a path for the electrons or the protons to escape, okay? So in this case, we're going to actually touch it with our finger, okay? So this is your mutated hand. I don't know how to draw it. But anyway, the symbol for grounding an object, let me do this in green here, is it's like a wire, like an electrical wire, and then it's three little lines that get shorter, okay? So if you've ever looked at a what's called a schematic diagram, we're going to look at that in our next unit for like electric circuit, you'll actually see the symbol a lot of times because you have to provide a ground wire for safety there, okay? It's also called an earth wire sometimes by electricians, like if you hire an electrician to rewire your home. So what is that going to actually do? Normally when you ground like an electroscope, like you touch it, you take away any extra charge, okay? It just goes into your body. That's how we get rid of it. I'm always grabbing the sink to get rid of the charge here. But let's think about it, okay? Do electrons like electrons? They do not. We had polarized this, right? We had separated the charges. But now, instead of the electrons fleeing to the bottom of the electroscope, where can the electrons flee now? Okay? They can run away. Run away, run away, run away. The electrons are going to run away from the electroscope and go into the ground, okay? And the positive charges were still attracted to the negatively charged rod, okay? So something is weird is going to happen. You're going to see the needle actually start to swing apart even more, because here's what's going to happen in the end. We're going to combine the last steps, okay? So in order for induction to work, you have to polarize, you have to ground it, but then you have to remove the ground first. You have to do this in this order, okay? You have to remove the ground, then the charged object, okay? And here's what's weird. Let's see if we can predict what's going to happen, okay? If we remove the grounding source, you have to remove your finger first, okay? If you remove the charged rod first, it'll end up neutral, okay? But if you remove the ground first, then the charged objects, what happened to the electroscope? If it lost electrons, okay, it's going to have a deficiency of electrons, so it's going to have an excess of what? Of positive charges. You see that? And since positive charges don't like positive charges, they're going to spread all out, and the needle will still show repulsion, but it's going to have what kind of charge compared to the original charged object? The same or opposite? Opposite. So here's what's weird. Charging by induction often involves ending up with an opposite charge from what you started with. But you charged without ever actually touching the original object there. Okay? Very important idea, especially as we try to develop cars with electric motors, and you might hear the terms induction motors, inductive charging. And wireless charging technologies takes advantage of this idea of induction. So in about 3 to 5 years, your next laptop, iPhone 7S, diamond screen, whatever, it's going to charge without even plugging in. Okay? So let's see if we can actually accurately test our prediction here. It's a 3-step process. Step 1, talk me through it. What do I want to do? I want to bring a charged object close but not touch it. That's called polarization. I separate out the electrons. Electrons don't like electrons. They run away down the shaft, down the needle, and you see charge separation. Then I do what? I ground it, okay? And I get a little spark. And I maybe should take my shoes off because my feet are pretty sweaty. That's okay. And now the electrons go where? Into who? Into me. You see that? Then I remove my finger. I remove the source, and aha! Okay, how do we know that there's a charge there? The needle stays what? Stays separated. You see that? Now eventually it should stabilize once it reaches equilibrium. There we go. And how can I prove that? What kind of charge is there? A what? A positive charge. If I bring this close and this is negatively charged, will the needle swing further apart or closer together? It should swing closer together, which we see there, right? Okay? That's cool, right? So induction is the hardest one to picture because it involves a 3-step process, okay? That's why I really like this visualization where you see the 3-step process, okay? First you polarize, then you ground the object, then you have to remove the ground, otherwise all the charge escapes and it's neutral. And then you end up with a, how do I know this is positively charged? 1, 2, 3, 4 electrons, but 1, 2, 3, 4, 5, 6 positive charges, okay? And there you have it, induction in a nutshell, very important idea, okay?